Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is determinants. This is an introductory video on this topic. Now question comes, what is a determinant? We have learned matrices in the previous videos. Now when we transform a matrix into a one simple number, a scalar, a determinant of a matrix represents a single number. It is called a determinant. So when A is given some matrix, this is a 2 by 2 matrix. It can be any matrix. Then its determinant will be given by mod A or written as det A or this delta symbol. How do we get that single number? That we will see in subsequent part of this video. For a 1 by 1 matrix, the determinant is the number itself. For example, if we have a matrix A equal to 15, this is a 1 by 1 matrix, then its determinant is 15 itself. The determinant of a matrix of order 2, let this matrix be this, which is a 2 by 2 matrix, then its determinant is given by this mod symbol we will add. Then we write the elements one by one similar to this, and the answer will be multiplying these two numbers first. So A11, A22 will be multiplied first, then we put a negative sign and then we multiply these two numbers. So that's what is given here. We can write one example, say A equal to 1, 2, 3, 4. Then determinant A will be 4 into 1, which is 4. Then we put a minus sign, then multiply these two elements. 2 into 3, 6. So equal to minus 2. So we have basically written the full matrix into a single number. That's what determinant is doing. Determinant of a matrix 3 by 3 matrix. We want to find it out. So how do you get it? We first write the first element A11 we write, and along with that which sign to use, we use this expression minus 1 power I plus j. So this is ith row and jth column. So this is exactly what we are doing in this. So this will be minus 1, 1 plus 1, ith row and jth column. Then we, since we have selected this element, we remove these two rows and columns. Where element A11 is there, corresponding to that row and column is removed, and the balance, this is the balance matrix that we write, we find the determinant of that. So we have written A22, A23, A32 and A33. In the next we write minus 1 power 1 plus 2. So minus 1 power 1 plus 2, the second element A12 we add. Then since we have selected this element, we remove corresponding rows. This row will be removed and this column will be removed. So balance will be this matrix. That's what we have written here, A21, A23, A31, A33. We know how to solve this. This is a second order determinant. We have seen it earlier, how to solve this. So in this way, a third order matrix can be found its determinant. We will see one example. Let us take one example. We want to find the determinant of this 3 by 3 matrix. So we start with the element 3. We write the element 3. Then remove corresponding column and row associated with this element 3. We are removing. So balance will be 1, minus 2, 3, 1. That's what we are writing here. Next we put a minus sign because this is minus 1 first row, second column. So this will be 2 plus 1, 3, minus 1 power 3 is with a minus 1. So we are selecting minus here. Then take the second element minus 4. Now since we have selected this element, we remove this row and this column. Balance will be these elements. That's what we have written, 1 minus 2, 2, 1. Next we select 5 and similarly remove corresponding column and rows from that. Balance will be this elements 1, 1, 2, 3. That's what they have written here. This we know how to solve. First we multiply 1 into 1. Then we put minus 3 into minus 2, which is 1 plus 6 into 3. This will be plus 4. This will be 1 into 1 is 1. 2 into 2 is minus 4 plus 4. This will be. Similarly 1 into 3 is 3. Minus 2 into 1 is minus 2. We get simple algebra operation answer as 46. So this is the value of this determinant. We can write this full determinant of this matrix as 46. Now area of a triangle with vertices, this is given by this. What do you mean? Let us have a triangle x1, y1, x2, y2, x3, y3. Then the area of this triangle, is given by half into x1, y1, 1, x2, y2, 1, x3, y3, 1, where x1, y1, etc. are the coordinates of this triangle. So we have to find the determinant, multiply by half, we'll get the area of the triangle. Now what is minor of an element? Minor of an element Aij of a determinant of order n is the determinant of the square submatrix of order n minus 1 obtained by leaving the ith row and jth column. That we have seen earlier. For example, if you want to find minor of second row, third column, which is this, we want to find minor of this element. So we have to remove this row. So we'll remove this row and this column. So balance elements will be 1, 2, 7, 8. That's what we have written. We have to find determinant of that. 8 into 1 is 8 and 7 into 2 is minus 14. 8 into 1 minus 7 into 2 is 14. So 18 minus 8 minus 14 is minus 6. This is the minor of this particular element 2, 3. Cofactor of an element Aij denoted by Aij is the minor along with this sign change. So cofactor is nothing but the minor matrix into the sign, whether we have to take positive or negative. It is given by this minus 1 I plus j. This will give the sign whether mij will be positive or negative. If the sum is positive or sum is even, then mij will be positive. If I plus j is odd, the sign of mij will be negative. Let us take one example. We need to find cofactor of the element A23. We already know M23 will be removing this row and this column 1, 2, 7, 8. Balance 1, 2, 7, 8 will be put here. Now which sign will come? That is minus 1 power 2 plus 3. 2 plus 3, which will be a minus sign only. So that's what we have put additional minus sign here. So the difference between minor and cofactor is that in cofactor matrix or cofactor element, additional sign will be put along with the minor. Now we come to adjoint of a matrix. So we have written the cofactor. When we compute cofactor of all the elements, we get it as a cofactor matrix. So this is the cofactor matrix for this matrix A. We write it as A11, A12, A13, A21, A22, A23, A31, A32 and A33. Now the transpose of cofactor matrix. Transpose of cofactor matrix is called the adjoint matrix. This is the adjoint matrix. What is a singular and non-singular matrix? A square matrix is singular if mod A equal to or determinant of A is 0. A square matrix is said to be non-singular if determinant A is not equal to 0. We will be interested in this condition when we are finding the inverse. We will check this later. Some of the important theorems we have to do or learn in determinants is in theorem 1, let A be any square matrix of order n, then A into adjoint A is equal to adjoint A into A equal to determinant of A into identity matrix of that order. So we'll just remember this. If A and B are non-singular matrices of the same order and AB and B are also non-singular matrices of the same order, that is, if determinant A is not equal to 0 and determinant B is not equal to 0, then determinant of AB is also not 0 and BA is also not 0. The determinant of the product of matrices is equal to product of their determinants. This is also well-known theorem, you must remember. Now we have seen in previous video what is matrix inverse. If AB equal to BA equal to I, then B is called the inverse matrix of A. So B equal to A inverse and also A will be equal to B inverse. So we write this as A inverse equal to 1 over determinant A into adjoint A. This is a matrix. So A inverse will be a matrix. We know adjoint A, that is transpose of the cofactor matrix. Cofactor matrix transpose is the adjoint A. So a square matrix is invertible if and only if A is non-singular matrix. So this is very important. We have seen earlier that if mod A determinant A becomes 0, it is a singular matrix. If it is a singular matrix, A inverse is not defined because 1 over 0 is not defined. So that is why for A inverse to exist, mod A should be or determinant A should not be equal to 0. This is important. So far we have learnt like inverse and all, but where do we use the basic application of matrices in solving linear equation? This is very important. So we take a linear equation here, a two variable equation x plus 2y equal to 4 and 3x minus 5y equal to 4. So we write in matrix form. You may be wondering, for solving these two simple linear equations, we use matrices. It can be simply solved removing one of the variables and we can simply get the answer. You are right. But thing is, in actual application, there may be hundreds of linear equations we need to be solved simultaneously. Then using this standard approach will be difficult and we use matrices for that purpose. So let us write this simple example in matrix form. We write the coefficient 1, 2 and 3 and minus 5. Then write x and y and write the RHS as 4, 1. So this matrix can be written as A, this matrix can be written as X, and this matrix can be written as B. So we write it as AX equal to B. Our aim is to find X and Y. So that matrix can be evaluated as X equal to A inverse B. So we will be needing that inverse matrix computation to get directly the vector X, column matrix X. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.